This is question 4 from the second CSAT sample paper. In this question we've got 3 regions A, B and C and they overlap, and we're using this mod sign to mean the area, or I'll just call it the size. I'll just refer to these as A and B and C, and this is the union of them, so I won't just talk about the size or the area. So this is saying A and B are both 90 and C is 60, and the union of all of them is 100, and we have to find the smallest possible value of the intersection of all of them. So if you want to have a go at this question yourself, pause the video now. Okay, so first of all, it's easier if we draw this information, so let's draw this. We can do this a lot like a Venn diagram. We just got 3 overlapping regions. We don't really care about the shape, but we'll draw them roughly as circles. So I call these outside bits U, V and W, and then these intersections, so say for instance X is the intersection between A and B, but doesn't intersect with C. So this is X, Y and Z, and then the intersection of all of them is M. And this M we're trying to find, or the size of M we're trying to find. So let's write down the information we were given in terms of the letters I put in this picture. So first of all, we were told the size of A was 90, and A is U, X, Y and M. So if we add all of those together we get 90. Likewise for B we have V, X, Z and M, adding to 90. For C we have W, Y, Z and M, that makes 60. And the other thing we told was the size of the union of all of them, so that's all of these letters added together, and that was equal to 100. And I'm going to call this equation 1 because I'll come back to it later. But these ones I want to rewrite. Why do I want to rewrite them? It's partly to make the numbers smaller and partly to get rid of M, because I think it's easier when there's only one M involved. So we're told, for instance, that A has size 90 and the whole thing is size 100. So that means these 3, which are outside A, add together to 10. And we can do a similar thing for these 3 and for these 3. So V, Z and W, which are outside A, those have to add up to 10, because it's 100 minus 90. And then U, Y and W are outside B, so they add up to 10. U, V and X, so these 3 add up to 40, because that's 100 minus 60. And what do I want to do with these? Well, I've got to combine them with this somehow, and this has everything added together. So what I might think of doing is adding all of these together to get one big equation, and then I can compare with this. So let's try that. So if I do that, if I add them all up, I've got 2 U's from here and here, 2 V's, 2 W's, and then 1 each of X, Y and Z. Those are all added together and they make 60. So I've got this equation 2 because this is useful to compare with this, because it's got everything in except for M. So now what do I want to do? Well, the obvious thing to do is to take this away from that, because at least that will eliminate 3 of the letters. So let's do that, and I get M from here, and then we've got U, V and W, and then 2 of each of them here, so we get minus U, V and W, equals 100 minus 60 is 40. So now here it's worth saying we're looking here at 7 regions, U, V, W, X, Y, Z and M. And we've got 4 pieces of information, so we've got 7 unknowns, 4 pieces of information. And that means we can choose any 3 of these values. Obviously there are limits, like because V plus something equals 10, we can't have V bigger than 10, and so on. But once we choose 3 of these values, that fixes the other 4. And now I've got an equation where I've just got M and then 3 values, so it makes sense to try to fix these to make M as small as possible. It's also worth noting that because we've got, say, these 3 things adding together to be 10, at least V and W, and here U and W, so all of U, V and W have to be quite small. So we might actually try to make these 0 and get M equals 40. So first of all, from here we can read off M minus something equals 40. and therefore m has to be at least 40. So m is greater than or equal to 40. So it looks like the minimum value is going to be 40, which would be if this was 0. But just because we've shown this doesn't mean we've shown that the minimum value is 40, because it could be that, for instance, from doing some other manipulations, we could have got m is greater than or equal to 50, and then this would still be true, but the minimum would be 50 instead of 40. So it could be that m can't actually reach the value of 40. It might be that m has to be greater than and can't be equal to 40. So we need to check if we can make m equal to 40, and if we can, because of this equation, then we've got that the minimum is 40. So, as I said, the way to do that is to try to set all of these equal to 0, and then we just have to check that we can fill in the other values in order to make all our equations true. So if we do that, if we make all of these 0, then we can just read off z, y and x from these equations. Get z equals 10, y equals 10, x equals 40. So when these are equal to 0, z and y are 10, x is 40, and we do get m equals 40 in that case from this equation. And let's go back and check that those satisfy our initial equations, the initial ones we were given. This becomes 0 plus 10, plus 40 plus 10 plus 40 is 90. This becomes 0 plus 40 plus 10 plus 40 is 90. This becomes 0 plus 10 plus 10 plus 40 is 60. And this becomes 0 plus 40 plus 10 plus 10 plus 40 is 100. So all of those work, and therefore we've shown that m equals 40 is a possibility, and therefore because of this equation it is the minimum we can achieve. So 40 is possible, and therefore 40 is the minimum.